Hello, and thank you for listening. My name is Ken Raffa. I'm an emeritus prof at UW-Madison. And I'd like to start out by thanking the Western Forest Insect Work Conference for bestowing this recognition on me. I really appreciate it. And I especially appreciate Nadir Ilbilgin for nominating me and the letter writers on my behalf. I recognize you're very busy people, and I really do appreciate your time. I also want to thank NAFIWC for being so flexible during these times. Normally, a founder's talk would be an after dinner talk when people were drinking wine and beer, but like the old song says, it's 5 o'clock somewhere. I mostly want to thank my wife, Anne, my wife of over 40 years, my best friend, and the love of my life. She's been so supportive through everything, and she's opened up our home to all of my students and colleagues, and many of you have had the pleasure of interacting with her. And I also want to thank my daughters, Annie and Kathy, who likewise have been so supportive and have joined me often in the field and at meetings. And they continue to be my main source of IT support as well. I want to give a big thanks to all of my students and postdocs because they really provided the intellectual energy and the physical energy and the enthusiasm behind everything we've done in our lab. And I'm continually learning from them. And finally, I'd like to thank all of the collaborators I've had over the years. And you folks have brought new methodologies to our lab and have complemented what we're doing, and I'm very appreciative. And my good friend Dan Herms at my retirement dinner had actually calculated that over the years I had co-authored papers with something like 280 different people. And fortunately, he didn't calculate how few people have been willing to write a second paper with me. Uh, Over the course of my career, I've seen some tremendous strides in forest entomology, and I've categorized them here as methodological, disciplinary, and cultural. And if you look at the methodological advances, I'm not going to read them here, you can see them, but they really brought about what I think are two major changes. One is we see far more studies that span many different layers of biological organization. And then secondly, we see more and more studies that are able to successfully link pattern with process. When I look at the disciplinary changes, certainly when I started in my field, trees were viewed as these very passive entities, almost like the damsels in distress of old folklore. And we now know that trees are badasses. Trees respond viciously to any kind of attack, and that most of the time, insect outbreaks are the exception rather than the norm. And when we do see outbreaks, it's often a signal of some kind of environmental perturbation that we should be aware of. And likewise, when I began, symbioses were viewed mostly through the lens of vector relationships, which indeed are very important. But we now know that all aspects of insects' lives are linked very closely to associations with a broad range of bacteria, fungi, and other organisms. And often these symbioses are multipartite and multifunctional. Likewise, population models throughout much of my career were based on tabulating individuals. And there was the implicit assumption, even though we knew it wasn't true, that all of these individuals were alike. And now that we have the molecular tools to look at the genetics behind things, we have much stronger appreciation of the genetics of the insects involved, their host plants, and their symbionts. And then finally, the fourth area I would highlight would be landscape ecology, which was just in its infancy during the early stages of my career. And now it's achieved tremendous fruition in management of forest pests. Landscape ecology is really the driving force behind successful programs such as the Gypsy Moth Slow the Spread program, our modeling of movement of invasive species across landscapes, and range expansion in response to changing climate. Among the cultural changes, the most prominent I've seen is the vastly increased role of women in science. You only have to look at the photographs of early meetings to get a realization of how few opportunities there were for women. And now women have prominent roles in every aspect of our research, teaching, and outreach and administrative undertakings. We've also seen some improvement of inclusion of minority students, but we still have a really long way to go in this regard. Fortunately, some universities have begun some partnerships that show some real promise. The third thing I would mention is the science has become increasingly interdisciplinary and increasingly multi-purposed. And by that, I mean, early in my career, much of forest entomology was uh, attentive to the production aspects of forestry, which indeed is very important. But now there's more incorporation of ecological services and the urban sector. And then finally, a really good improvement is over these years, there have been a reduction in the barriers between so-called basic and so-called applied research. And I think a driver behind that has been our changing notion of what applied science is, where at one time it primarily dealt with forest products, and now it also includes issues like climate change and invasive species. Now, if you just kind of step back and look at the major advances in overall ecology and entomology, and I'm not talking about forest entomology per se, but just these broader fields, what you can see is a disproportionate contributions by forest entomologists. And so if you look at these major advances that I've just listed here, and say start with the 1960s when there was an appreciation for life tables and quantitative sampling, for example. You can't possibly talk about those areas without talking about the work of folks like Morris and Baltonsweiler and Wellington. And likewise, if you wanted to talk about the burgeoning area of pheromones during the 1970s, you couldn't possibly talk about that without mentioning work by folks like Dave Wood and Ring Carday. And that pattern goes all through these advances. For example, if you look at the area of plant-insect interactions, the two most widely cited papers in that field are Bill Matson's paper on the role of nitrogen in herbivore development and the growth differentiation plant hypothesis by Dan Herms and Bill Matson. And likewise, if you look at the recognition by the Entomological Society of America in its various awards to graduate students and faculty, you'll see a disproportionate portrayal of forest entomologists. For example, if you look at the Lifetime Fellow Awards over the last 5 years, there's been an average of one forest entomologist in each of those years represented. And that really is disproportionate to our numbers. And so I wanted to just step back and look at why I see reasons for forest entomology being particularly conducive to doing impactful science and particularly well positioned for approaching the major challenges that we have in front of us. And the first I'd list is the relatively less manipulated nature of our ecosystems. On average, forests have typically undergone less of a human sieve in terms of genetic selection and management and disturbance regimes than agricultural or urban entomologists. And so this gives us better opportunities to observe directly how natural processes function and to infer some things about feedbacks that can be useful for long-term approaches to management. Secondly, I would list the remoteness and scale of forest. And this is often viewed as a disadvantage in terms of experimental design and implementation. But at the same time, I think it has always fostered an independence among our graduate students. The very nature of being a grad student in forestry is you're often far removed from your major prof. And that requires an ability to think on your feet because things never go in the field exactly the way they were planned in the lab. And that also necessitates teamwork, both planned teamwork and spontaneous teamwork. I mean, our collaboration begins with the very physical fact that trees are too big for any one person to put into the truck, and you have to work together, and that fosters a collaboration that goes throughout our entire careers. And then third is that the economics of forestry are lower than those of agriculture and urban areas. And so that has always reduced the practicality of tools such as insecticides. And in turn, that has favored more long-term approaches that are based on understanding system properties and feedbacks. And the next I'd list is the synergy between university and government agency. And by that, I mean the US Forest Service, the provincial forest services, and state uh, DNRs, and Canadian Forest Service. And the synergy in terms of our missions, approaches, and capabilities. And of course, there is collaboration in other areas of entomology, but I have felt that in many times those are more additive rather than synergistic. And in the case of our system, the universities often contribute graduate students who bring their idealism and their energy and their new methodologies. And the state and provincial and government agencies bring the long view and the historical memory and the ability to conduct large scale experiments that far exceed the timeframes of university grant cycles. And I'd be willing to bet that almost all forest entomologists, no matter where you are in your careers today, during your graduate years probably worked very closely with government agency scientists. And then I would add the physicality of field work, the very nature of working physically in the field. We learn each other's strengths and weaknesses and capabilities, and that brings a certain kind of collegiality and humor and familiarity. And along with field work comes accompanying road trips. And there's something about long road trips that you get to know each other's idiosyncrasies, which is what makes us interesting. It gives students an opportunity to really confide in their mentors what their hopes and ambitions and fears are. And I always say there's something about it, you learn about each other's taste in music, you learn how to share that, and you learn everything about each other from your philosophy of life to your bladder capacity. And then finally, I think we're constantly enriched by the sheer beauty and wonder of our system. And as scientists, we often don't talk about this personal dimension, but actually that fosters our creativity and our inspiration. That's why many of us went into our chosen field. And I wanted to share with you a quote that I was fortunate enough to come across in graduate school, and it was by George Washington Carver. And he said, if you love something enough, it will reveal its secrets. And I've always appreciated that notion of the relationship between the scientist and the object of their study as a romance rather than as something you're trying to extract information from. And I guess the very last thing I'll mention is that part of being a forest entomologist is we're accustomed to being wrong. Working with nature is humbling, and we soon learn quickly that nature always gets the last laugh. We're never going to understand these complex systems completely. Being wrong means everything is simple, from getting totally lost in the woods to getting stuck in the mud. And this impacts how we interact with each other, because when we see results that are different from our own, Our reflexive reaction is it just kind of sparks a sense of curiosity about, well, what's different about that particular area of the continent? What's different about that particular system? And this often inspires collaboration that has led to some really wonderful large scale geographically expansive projects that many of you have worked on. So it's against that background of what unifies us and inspires us that I just wanted to share a little bit about my own personal career path. I was born in Irvington, New Jersey in 1950, and my parents were first generation Americans. All four of my grandparents were born in Italy, and I really marvel at the lives these folks lived. My mom completed high school early so that she could go to work in a factory to help support her family during the Great Depression. My father, likewise, his dad died at a very young age, so my dad was working at the age of 14, and then also fought in World War II in the European theater. And so neither one of them really had an opportunity for much formal education, but I was very much able to benefit from what they could teach me. We moved to Wilmington, Delaware when I was just turning 4, and the forest began just 4 houses down from our house. And so that opened up a whole new world for me. The 1950s, the baby boom years, was a period where there was tremendous unstructured time, and kids really did run loose and could explore whatever interested them. And in my own case, it was anything to do with nature. It wasn't necessarily insects per se, but deer and squirrels and climbing trees or whatever. It was all of equal interest to me, both through growing up and also opportunities through the Scouts and through high school. When I began college, entering a university really is an overwhelming experience for a first generation college student. And 1968 was a particularly overwhelming time because during this time there were everything from frat boys to hippies to radicals to jocks to just everything going on. And the guy in the room next to me was eating live chameleons for 20 bucks a pop. And so I really did struggle trying to figure out where I fit in with all this. I was originally a pre-med student, but never quite felt comfortable in that pre-med environment. Something else was calling me. Uh, During this time, I worked a variety of jobs. And in looking back, these jobs during the summer and during the academic year really did help prepare me for what I ended up doing. I mean, really, nothing can prepare you for applying for grants more than working in a bingo hall or a racetrack. During this time, I also competed in tennis at the varsity level in high school and college. And the truth of the matter is, the reason I got into tennis was because I was so terrible at baseball. Most guys don't suck at baseball until they're about 13 or 14. But I was very advanced. I sucked by the age of about 8 or 9. And so that gave me the opportunity to have kind of an early in, but it really was a rewarding experience in terms of learning what competition is like and recognizing that often the other person is just plain better than you. In 1972, there were very few opportunities for women in sports. And so a couple of women had approached a buddy of mine and myself on the men's tennis team and asked, why isn't there a women's team? And we thought, yeah, why not? And so we started one. And technically, we were just a club. They were not formally recognized by the NCAA until a few years later. But it really was my first mentoring experience. And we were very fortunate. Just we didn't have any kind of funding, but the men's tennis coach was very supportive and looked the other way as we stole balls from the men's team. The men's um, swimming team loaned their warm-up jackets, which is actually what you see the women wearing here from the men's swimming team. And the men's basketball coach allowed us to use the gym after it had been closed. And so that's how we did our late night practicing. After I graduated, I worked a variety of jobs and really wasn't sure what I wanted to do, but I just had this idea that it would be really cool to work for the Forest Service. In hindsight, it was really pretty naive because I'd never had any forestry classes. But fortunately, I got a call from Asheville, North Carolina, and the entire interview consisted of just one question. He asked me, "Do you have any fear of being in low altitude aircraft in mountainous terrain?" And I said, "No." I mean, how would I know? I'd never done it. And so I just immediately leapt at the opportunity. Asheville at that time was a much more rough and tumble place than it is today. At the time, I lived in an apartment directly above a Harley Davidson store downtown. They had me doing aerial sketch mapping and aerial photography. And back then, sketch mapping was a lot different. There was no GPS. And so you just had a topo map draped across your lap, and you would indicate where you saw insect damage. And then you would go in the following week and ground truth it. And at first, I really was not very good at it and often led to me and my colleagues being thoroughly lost in the woods until one of my coworkers pointed out to me that you really shouldn't be eyeballing it. You should be thinking about features of the landscape. Think about what types of patterns of vegetation you would expect to see in particular places, and then make those kind of estimates of where you are. And without realizing it, I was really being given my very first lesson in how to think across different scales of biological organization, something that I think did help me throughout my entire career. And it was also during this time I got my very first publication, a citation classic called USDA Forest Service Research Station Report number 74-104. I applied to the University of Delaware Department of Entomology and Applied Ecology for grad school, and I was fortunate enough to be hired by Professor Roland Roth. And Dr. Roth was a community ecologist who did all of his research in one woodlot, and he had us sampling squirrels and yellow jackets and vegetation and wood thrush and just about everything. And after I had been working there a while, he called me in and he said, "Well, I've been watching you at work and I have a special assignment for you." And I thought, this is pretty good. And he explained that because the woodlot was directly adjacent to the University of Delaware football stadium, that during half times people were leaving the stadium and relieving themselves in the woodlot. And so my job was to stay in the woodlot on football Saturdays and make sure that did not happen. I'm not sure how Professor Roth decided I was the right person for this particular job, but I can say with pride that when we did the vegetation sampling, there were no edge effects. I did my graduate research on biological control of gypsy moth, and in particular, I was looking for alternate hosts for two parasitoids that had failed to become established, Glyptopanoles porthetri and Glyptopanoles lepardus. And the thinking was that if we could find an alternate host through which these parasitoids could overwinter, they would then be established. In hindsight, I look at my master's career as a fortunate failure. Not only did I fail to find an overwintering host, but if I had, we would probably now call that a non-target effect. And so I think it illustrates just how much our interpretations of forest ecosystems and forest management have changed over the years. Towards the end of my career, Dr. Paul Katz suggested that I continue my education with a person he knew in graduate school during his University of California, Berkeley days. And his name was Dr. Alan Berryman at Washington State University. And I was very drawn to the kinds of things Dr. Berryman was doing because he was simultaneously asking questions about how conifers might respond to attack by herbivores, and at the same time doing some very interesting population modeling. And Alan Berryman was a force of nature. His willingness to engage in arguments during scientific meetings was legendary. Some of you listening to me knew him personally and were familiar with his fondness for a good argument. But I really learned three things from Alan. One was the value of robust population models, thinking in general but biologically defensible terms. Second was the use of theory to guide experimentation. And so theory is not just something that emerges from your research, but something that guides your day-to-day research. And third is the importance of feedback processes in complex ecological systems. I started out by working on interactions between grand fir and fir engraver and its symbiotic fungi. Most of that work was in northeastern Idaho, in northern Idaho. And during this time, I felt I learned some things about chemistry, but really I didn't feel I was making much progress in terms of the plant-insect interaction itself. And that's because the beetles seemed to be no match for the tree. The tree basically won almost every time. And so I switched and started working on mountain pine beetle and lodgepole pine in the Blue Mountains of northeastern Oregon. And here I had the opposite problem. When you look at a system like this, where almost every single tree is dead, you really feel the tree is no match for the beetle. But fortunately, because I had had these experiences with grand fir, it gave me some idea of what to look for. And with that, this really came my first appreciation of comparative biology. And again, that's something that stuck with me throughout much of my career. During this time, I worked on three major questions. How did trees defend themselves, and what metrics best predict tree survival in nature? Secondly, how does aggregation affect beetle success, and how does tree defense affect aggregation? And third, what tree properties do beetles use to select hosts? And this last one just kind of illustrates again how much our methodology has improved over the years. Because the way I approach this is I made extracts of pine trees, both polar and non-polar extracts, and I put them on kim wipes and then allowed the female mountain pine beetles to feed on them to see how much they would feed on extracts of various chemical properties. But the real challenge came, how do you then measure all these little feeding holes? And so the way I did it is I spread them between glass plates and took pictures with 35mm slide film. And those slides then became my raw data. And then we built housing onto the ceiling of our lab so that it could hold the slide projector and point it downward onto a table. And then we had a mechanical arm that was connected to a computer monitor. And I wrote a program to interface that mechanical arm with the monitor, which was connected to a mainframe. And then I would trace every single one of these holes and direct it to the mainframe for subsequent statistical analysis. I mean, now you would just take a picture with your smartphone. When we left Pullman, Washington, we drove cross country and we really made very few stops along the way because I had absolutely no confidence in my car whatsoever. It was giving us trouble the entire way and we never knew when it would totally break down. And ironically, we only gave ourselves one day of pure relaxation during our cross country drive. And that happened to be in Madison, Wisconsin. And this is a picture of the lake right along the campus. And little did I know that this ultimately would become our home. I spent 4 years working with DuPont Agricultural Products. And here I worked on insecticide discovery, anti-fedans, elicitors of plant defense, what kind of compounds could trigger defense pathways, and insecticide resistance management to present biotype evolution. And that led to a paper in Science, which is just interestingly enough, really is what got me thinking along the lines of how to prevent biotype evolution for genetically engineered trees, a paper that eventually appeared in Bioscience. And that actually formed the basis for a collaboration with a number of fellow scientists over a period of about 15 years. I applied to University of Wisconsin and was fortunate to get a job there. And this is where I had most of my career. When I first arrived at UW, one of the faculty said to me, you know, Ken, we hired you out of curiosity. When we asked you what kind of startup package you needed, you told us you needed a truck, a gas chromatograph, and a chainsaw. And we decided that was either the title of the worst country western song ever or an interesting research program. And fortunately, they bet on the latter. UW is a wonderful place where there are absolutely no barriers to collaboration, no institutional barriers at all. And there really has been no micromanagement throughout my entire career there. It's affectionately been referred to as the house that anarchy built. I think it says volumes about UW that when the campus was first designed, the founders took the very best real estate of the entire campus and devoted it to drinking beer. Madison was also a great place to raise my family. My daughters were able to grow up with the same kind of freedom running about that I had as a boy in Delaware during the 50s. Uh, Over the course of the career, I worked on a number of different things. And one of the wonderful things about forest entomology is you can afford to be a generalist, but at the same time emphasize certain disciplinary areas. And so for purposes of this talk, I just went through all my publications and categorized them in terms of the insects I worked on, and also in terms of the disciplinary areas. But across all of these different projects, I tried to keep three things in mind all the way through. One is, what are the key interactions and mediators that drive populations? Second, where are the feedbacks and how do they function? And third, how can we manipulate these interactions and feedbacks to keep insects below damaging densities? Perhaps the most rewarding part of being a professor is the opportunity to mentor undergraduate and graduate students. And I've just listed here where my students happen to be, where my former graduate students and postdocs are today. And I'm really very proud of how much they've been able to accomplish. But more than anything else, I think there's two things in particular that I'm really proud about my former students and postdocs. One is that each of them blazed their own trail. They didn't necessarily emulate what I was doing. Instead, they launched things in their own vision. And I'm very, very proud of that. And second is that they were always willing to help each other. Whenever a new student would enter my lab, I wouldn't hesitate to contact a former student who had perhaps developed the methodology they wanted to use. And that former student would always welcome the person into their home and walk them through the new methods, have a beer with them, and probably tell a bunch of embarrassing stories about me. Almost all entomologists are involved in K through 12 education, and this is one of the highlights of our profession, I think. But in addition to that, Anne had the vision to kind of flip that and not just teach students about insects, but rather use insects as a device for inspiring students to read. She was a reading instructor and dealt with students who, for a variety of reasons, were struggling and were in the lower parts of their class. And so she would prepare them for my arrival by having them do various matching games between action words like jump and fly and sting and various insects. She would have them write questions such as the ones that are written here. And I really marvel at the insightfulness of the questions some of these kids uh, came up with. And she would also have them write poems and haikus. And I've shared a couple of them with you. I think there's a couple reasons why children are so drawn to insects. One, I think, is in a child's world, almost everything is bigger than them. And insects are an exception. And so children often feel very protective towards insects. And I think the other is children can sense that if adults had their way, they would even get rid of insects. And so that children kind of recognize insects as kind of a thumb in the adult world's eye and are sort of drawn to them for that reason. Again, one of the great things about being a forest entomologist is you never really totally leave the field. You just reprioritize your time. And so now a lot of my time is spent with my grandkids and enjoying pedaling and paddling. But I'm continuing to be involved in a number of collaborative efforts. And one is with a group of wonderful colleagues, many of whom you'll recognize in this photograph, trying to assess the risk of invasive species. And also, I'm very much involved in collaborating with our State Department of Natural Resources and Department of Ag in advising them on a variety of forest health issues. So rather than show any actual highlights of my research, I just wanted to share with you some lessons learned. One is that in spite of all those methodological advances I talked about, there is still tremendous benefit to just plain sound observation. And I wanted to illustrate that by some work with a postdoc in my lab, Jasmine Cardoza. Jasmine was a chemical ecologist working on bark beetles with us, but she also used to just spend a time watching spruce beetles as they excavated their galleries. And she noticed that as they were doing so, they were egesting these fluids and then spreading these fluids along the sides of the gallery using their tarsi. And so she was curious about that and located bacteria in those egestions and found that those bacteria had properties that inhibited antagonistic fungi that would otherwise overrun these beetle galleries. And that actually formed the beginning of about 10 years of collaborative projects on these bacteria. The second is that I mentioned earlier the value of collaboration, and there really are, I think, ingredients to effective collaboration, and I've listed them here. One is I think it's important to have overlapping interests, but complementary skill sets. Otherwise, the collaboration is additive, but not necessarily synergistic. Secondly, I think it's important for each partner to have their own big picture into which this collaboration fits as an important piece. And I wanted to illustrate that with my collaborator, Joe Handelsman in the UW Department of Bacteriology. I was interested in how gypsy moth are able to contend with plant defense chemicals and the role gut bacteria might play in that. And Joe was interested in the community ecology of bacteria that inhabit extreme environments and what environment could be more extreme than the midgut of a lepidopteran with a midgut pH of around 9 or 10. And so it made for a really good fit. Likewise, I think it's good if you have similar approaches to problem solving and equal levels of commitment, but complementary approaches to inference. And again, I point to the work that Joe and I did with the role of gut bacteria and insect susceptibility to Bacillus thuringiensis. And it was really her insightfulness and creative thinking that really led to the general principles that came out of this. And finally, you have to enjoy interacting with each other, and you have to mutually benefit from debating different perspectives. Notice what I do not include on this list is administrative structure. I know administrators like to agonize over how best to arrange people so that they'll get the most fruitful collaborations. My own experience, it's really a much more organic thing. It kind of bubbles up from the bottom, and people find who they'll best collaborate with. And the last three things I wanted to share are here. One is that most ecological relationships prove to be multifactorial. So it's more useful to design experiments to detect how processes interact than to calculate which is most important. And next, our approaches to management should be with the view that native insects are functioning residents, not enemies of forest. And as functioning residents, they are sometimes our competitors. And I share with you a quote that was in a chapter by myself and my good friends Jean-Claude Gregoire and Staffan Lindgren. And we said bark beetles and humans are both in the business of converting trees into homes. So that makes some conflict of interest inevitable. And finally, science is a human undertaking. Even though the process of science is objective, the questions we ask, the settings in which we are most creative, and the scales at which our aptitudes are best realized derive from early formative experiences of our environmental surroundings, historical context, family, and culture. And I hope my reflections on my own career help illustrate that. And so as we look ahead, the last thing I want to leave you with is we are facing some important challenges such as climate change and invasive species and habitat fragmentation. And there are some overarching challenges to how we will succeed and the extent to which we're going to succeed. One is that forest, multiple and competing values bring different desired outcomes. And what I mean by that is if you look at a cornfield, different people may have different views on how to manage that cornfield. Some may favor insecticides or biocontrol or host plant resistance, but there's no disagreement on what a cornfield is for. That's not the case in forest. When you look at a forest, some people see a livelihood, some people see a place for recreation, backpacking, hunting, or fishing. Others may see ecological services such as carbon sequestration or biodiversity. And so we have to deal with those kind of different values and base our management plans accordingly. And to illustrate that, I wanted to share with you this sign that was along a trail in the Bavarian National Park. And they erected it right after a large outbreak by Ips typographus. And you could see the remnants of the trees behind it. And on both sides of the panel, the proud father is saying to his father or daughter, "This is the future of your forest." And on one side, he's pointing to a much more traditional productive type forest. And on the other side, he's pointing to a much more uh, diverse and disturbance adapted type forest. And I always enjoyed this as a good way of recognizing these different value systems. But then the second challenge is knowing this, we've come to learn that you need to manage forests on very large time scales and very large spatial scales. But the scales needed for ideal management are a lot different from the actualities of political terms and jurisdictions. For example, the political uh, directives may vary every 2 to 4 years in a system that we need to be managing on a scale of decades. And third, all of these challenges are occurring on a changing template of climate and species distributions and range distributions and habitat structure. And so we have to ask the question, To what extent are the past lessons, such as the ones I just described, useful versus to what extent are those past lessons poorly applicable to future conditions? And then finally, we have to face the fact that there are shifting societal attitudes on scientific methods, facts, and even objective reality itself. And of course, our COVID pandemic has illustrated exactly that point. Fortunately, a number of forest entomologists have been very engaged in the digital media, very active on things like TED Talks and podcasts, and that really gives me a source of optimism. And so, thank you again for your attention, and thank you for all of the wonderful memories over the years. And I really wish you all good luck in contending with the difficult issues facing forestry. But I do hope you enjoy every moment along the way. Thank you.